we had 3 guesses, we might as well use them all. Let's try the exponential q of t, and we'll make it general. We'll kind of like the sinusoids, we'll put an a in front of it. E to the omega was what went in front of time, plus phi. Let's just stick that in there, because dq dt, well, the exponent just stays the same, but you pull down the derivative of this with respect to time, so it's a omega e to the omega t plus phi, and the second derivative, you pull just down another omega, a omega squared e to the omega t plus phi. All right, well, let's just plug them in. So the second derivative was a omega squared e to the omega t plus phi equals minus 1 over LC times q a e to the omega t plus phi. And we tell the equation, is this good? The equation says it's good if this is true, so the exponentials go away. Interesting. And the a's go away. Same thing. The equation says I don't care about the a and the phi, I only care about this omega. And it says it's good solution if omega squared is minus 1 over LC. Therefore, if omega is the square root of minus 1 over LC. But wait a minute. We know that L is going to be positive, and C is going to be positive, and 1 is positive. So we've taken the square root of a negative number. You can never take the square root of a negative number. That's an imaginary number. So we can't have an imaginary number in our solution. So that can't possibly be right.
It's actually right, but I'm not going to cover it, so just read about complex exponentials.
Okay, now, that's our 3 solutions. This one is weird. We're going to stick with the sines and cosines. But the question is there another solution? I feel like there was, but I can't really remember it. So the question is there anyone that has the intelligence, the gravitas, the helpfulness that we all highly respect that could help me think of the next one? I'm trying to think who would know. Who would know? Oh, somebody is chiming in. Let's see if anybody knows. And it is Grove. Of course, Grove will know. And that final answer, of course, 0. Yes, 0 is the next guess that we could put in. Is 0 a function? Yeah, 0 is a function. Is it equal to its own second derivative? Sure. The first derivative of 0 is 0, and the second derivative of 0 is 0. So it follows all the rules. Is it a reasonable answer? Sure. Let's look at the circuit. Can nothing happen? Yes, that's a reasonable answer. It just sits there. That's often called the trivial solution. Of all the solutions you could pick, that one just is trivial, meaning it doesn't really tell you anything that's going on. So let's stick with the sines and cosines.